Good afternoon and welcome on this webinar on clean and affordable energy for a sustainable world. We will focus today on energy transition and long-term priorities. I am Monica Spada, chair of the OMC Med Energy Conference, and
I'm Edoardo Dellarole, chair of the program committee of the OMC event.
The OMC Med Energy Conference was launched in 1993 to provide a forum for information exchange and discussion of energy and technology trends, with a particular focus on the energy region. In over 25 years, the OMC conference and exhibition has grown into the leading event in the Med for energy insight, with a particular emphasis on the upstream sector. In more recent years, OMC has started to approach forms of energy from renewables, energy efficiency, low carbon economy to circular economy, with the scope of increasing the awareness about the complementarity of all energy sources. Its effect, more and more energy companies have committed to reducing or eliminating emissions in the medium-long term to fight climate change. In this new scenario, we are even more committed to offer a wider perspective, expanding OMC horizon. The 15th edition of OMC aims to discuss the challenges of the energy transition, starting from the path that the energy company have started in the last decades towards a low-carbon energy mix, with a holistic perspective, enlarging the boundaries of its activities, including their different source of energy, with a more diversified energy players section. I leave the floor to Edoardo to show us some figures about the energy transition path.
Thank you, Monica. Today is the World Day to combat desertification and drought, and it follows the World Environmental Day, the United Nations Day for encouraging worldwide awareness and action to protect our environment. Many policymakers, institutions, associations, and people are asking to accelerate on the green path toward a low-carbon future. The energy sector is the source of around 3/4 of the green gas emission. Today holds the key to averting the worst effect of climate change. The International Energy Agency showed that the world has a viable pathway to building a global energy sector with net zero emission in 2050, but is narrow, and it requires an unprecedented transformation on how energy is produced, transported, and used globally. A transition of such a scale and speed cannot be achieved without sustained support and participation from citizens whose lives will be affected in multiple ways. We need to aim at a transition to a net zero energy system by 2050, which ensures stable and affordable energy supplies, providing universal energy access and enabling robust economic growth. This means providing electricity to around 800 million people who have no access to it, and clean cooking solution to 2.6 billion of people who lack them. The transition must be fair and inclusive, leaving nobody behind. We have to ensure that developing economies receive the financing and technological know-how they need to build out their energy system to meet the needs of their expanding population and economy in a sustainable way. By 2050, the energy world will look completely different for sure. Energy efficiency, electrification, renewable power are some of the main drivers, but the transition calls also for major increase in all sorts of flexibility and synergies between the energy sectors. The final pictures and the path we will follow is the argument of many scenarios and reports, but a unique figure does not exist. Why? Because a unique solution does not exist. We have to face both old and new challenges, from global warming and energy assets to critical minerals and cybersecurity. Finding a new holistic perspective, defining strategic synergies and alliances between the energy stakeholders could be an effective way to speed up the transition, and OMC want to act as a big facilitator on this process. So I think now it's time to discuss together. Monica?
Thank you, Edoardo. Let me introduce our guest. Stefano Campanari from University Polytechnico of Milan, who is specialized on low carbon energy system. He's professor of energy system and environment and member of the board of Applied Energy. Andrea Contin, University of Bologna, Campus Ravenna, who is professor of environmental sciences, specialized on bioeconomy and energy system analysis. He worked for about 20 years at the European Center for Nuclear Research in Geneva. And Francesca Verga from University Polytechnic of Turin. She's professor of reservoir engineering, underground energy storage, and CO2 and hydrogen underground storage. She is vice rector of international affairs at Polytechnic of Torino. Finally, we will have the closing remarks from Paolo Carnevale, chairman of the Italian section, and Fausto Torri, managing director of energy industry of Accenture. With them, we will discuss about the energy hackathon that will take place in Ravenna, the next OMC edition in 2021. So let's start.
Thank you, Monica. So, Stefano, in the energy debate, one of the today hot topics is for sure hydrogen and its potential for a decarbonized and efficient energy sector coupling. Most analysts agree that the futures of hydrogen is still uncertain. So, Stefano, we are really at the beginning of a hydrogen economy?
Well, okay. Hydrogen is surely expected to be one of the main players in the future decarbonized economy. In this presentation, I will try to show how especially it can interact with the all energy sectors, basically, through the so-called energy sector coupling concept. Okay, let me see if we are ready to change. Okay, so this presentation will briefly address, on one hand, the context and the motivation for that, and some example of how the sector coupling really could behave in connection with industrial uses and transportation uses. The general framework is that hydrogen is considered in a way complementary to electricity, a clean energy vector, one of the very few which are able to be clean from the generation to the final uses, like electricity. So a versatile vector which can be applied and can interweave with a number of energy sectors. By the point of view of the framework, we had the last year the formal declaration from the European Union of a quite complex and branched hydrogen strategy, which is aiming exactly at using hydrogen for linking different energy systems. So it is aiming at an energy system integration in general, where the role of hydrogen, together with electricity, together with electrification and other possible clean fuels, is indeed to connect in a flexible way the different infrastructures and parts, let's say, of the energy system. The European Union is promoting specifically the deployment of large-scale installations for hydrogen generation through electrolysis, as an example, as a way to promote the transition towards the use of hydrogen. But we are not talking only about Europe. Also in the US, the framework is favorable to the evolution of the hydrogen economy, we can say. There has been always a strategy related to the promotion of hydrogen through the Department of Energy. In the latest year, in particular, the program Hydrogen at Scale is financing remarkable projects for the use of hydrogen. And I may mention, well, like a small advertisement versus our university, that we also won a grant in this program together with the University of California in the field of clean steel production. But apart from that, it is nice to see that recently the new administration, the Biden administration, declared the launch of the Hydrogen Earth Shot, which is a new initiative, was announced just a few days ago, to accelerate the breakthrough towards a net zero economy based also on the use of hydrogen. Hydrogen can be produced in several ways. Unfortunately, we don't have it by itself. It is typically connected to carbon or oxygen, either in hydrocarbons or in the water or other substances. So the classic production of hydrogen is from steam reforming of natural gas, for instance, and that is labeled gray hydrogen by a nomenclature point of view. With the addition of CO2 capture, it is then labeled blue hydrogen, and that would be a way to keep using fossil fuels, of course, but cleaning the production of hydrogen through CO2 capture. In alternative, there are several other possibilities, but in particular, from electricity, you can generate hydrogen through electrolysis. When you get clean electricity from renewables, in that case, hydrogen is labeled green. That could also be generated by other renewables, but let's say the use of electricity is one of the most considered. As a matter of fact, using electricity brings exactly in the direction of sector coupling with other energy systems, and in particular with the power generation systems. We all expect an increased role of renewable energy sources, and in all countries where there's a great potential for photovoltaics and wind deployment, like is for Italy, there is also the prospective necessity of having systems for energy storage, not only on a daily basis, but also on a seasonal basis, let's say over long periods. You see here on top right an example of the monthly imbalance in photovoltaic production in Italy, where we have nearly 2 terawatt hours of difference in electricity generation from winter to summer months. That is expected to become bigger in the long term due to the increased deployment of photovoltaics. And so it brings to the necessity of considering large-scale storage systems able to move energy not only on a daily basis, but also on a weekly or even seasonal basis. And here it is considered that the generation of hydrogen as a mean of energy storage is probably one of the most competitive possibilities for that kind of application. We did a study, for instance, on the case of California, together with the University of California, for a scenario with 100% renewable energy source electricity generation, and we clearly concluded that the amount, the cost associated with such type of storage system could be reasonably, let's say, affordable for the California community. Going further, it is, however, important to keep in mind that there's a transition towards such long-term scenarios where it is quite plausible, if not necessary, to expect a role not only for green hydrogen from renewables, but also for the already mentioned blue hydrogen, which can be produced with consolidated and well-known technologies already demonstrated at large-scale industrial projects, and having also already demonstrated a cost competitiveness, let's say. So those could really help in helping in sustaining the diffusion of hydrogen use and support the transition, let's say, towards a future complete renewable-based scenario. That is also connected to economics. Nowadays, blue hydrogen is less expensive if generated at a large scale versus green. And although the green option is expected to become more and more competitive in the future years, we can see clearly by this figure as an example, which comes from the International Renewable Energy Association, there's a transition to be done before the green option is more competitive than the blue one in this case. However, going through this transition, the role of hydrogen should be to act as a kind of energy hub, so allowing to link different sectors in the sector coupling concept, basically supporting both the evolution of transport towards zero emissions, but also the evolution of industry towards a decarbonization, and as I mentioned, also helping in the field of energy storage, as well as in the other type of final applications that you may see from this picture. One typical example of industrial use is the case of steel production. Primary steel is nowadays generated with the conventional process, which uses coal-based syngas as a mean for generating iron. However, that process can be substituted with processes which are already experimented at large scale based on different using gas, which would be hydrogen. And that would avoid all the CO2 emissions connected with the use of coal. That is an example represented in this slide. Others, always related to industry, are, for instance, those in the field of ammonia production. Ammonia and fertilizers are produced in increasing important quantities worldwide. And the production of ammonia is nowadays based on using fossil fuels, in particular steam methane, to generate hydrogen, which is then combined with nitrogen to make ammonia. Well, the alternative, the so-called second generation process for ammonia production, is based on using hydrogen from electrolysis. So again, connecting with the power generation field, another energy system, which is the one of industrial uses, in this case in the fertilizers industry. Finally, it is important to mention the application to mobility and transport in general. There's an increasing availability of vehicles nowadays in demonstration fleets, mainly both vehicles for passenger transport or vehicles for larger scale uses, and vehicles using hydrogen as a fuel, typically through fuel cells of the polymeric type. And that availability is expected to grow in future, where several countries have set ambitious targets in the mid to long term to deploy increasingly large fleets of such type of vehicles. One of the most famous ones is the Toyota Mirai, which you see below in the field of passenger cars, which recently set a new world record for driving on public roads for over 1,000 kilometers on a single fill of hydrogen, and then being able to refill again in just 5 minutes. So that would allow to keep the traditional flexibility of fuel-based vehicles with the advantage of the zero emissions. In the field of transport, one of the most considered application is heavy transport, indeed, because in that application, the use of a fuel allows to avoid the loss of payload, which is otherwise entailed by the use of battery-based solutions. So you don't have the necessity to carry on board a too heavy battery. Also, you don't have the issues with high energy and high power charging, which would be increasingly difficult with increasingly high power vehicles like the ones you see in this picture. And that is a kind of application where hydrogen is expected to play an important role. Overall, we see a prospective proposal of a sector coupled scenario, as I mentioned, where the different energy applications are connected as represented in this slide, which is proposed by the European Hydrogen Strategy, connecting, as we said, the power generation, the final uses with hydrogen as a kind of hub. A hub which also has to be coupled with the existing infrastructures. Here you see a more complex diagram showing, however, how the power to hydrogen conversion, which is in the center in green, is able to connect the power grid on the left, the natural gas grid below, which could be, let's say, subject to injections of mixing of hydrogen, but also could become, in some parts, a new grid able to transport pure hydrogen as well. So, let's say, renovating the use of existing infrastructures in a clever, smart way. Let me finally recall that hydrogen can be transported after generation, can be transported, of course, on the road. Today, we see tube trailers as a means for transporting hydrogen, but in perspective, large quantities could be also transported by pipelines, as today we see for natural gas. So, again, adapting and making use of an infrastructure which is valuable and is strategic for many countries. That could also allow an efficient interconnection at an international level, so at very large distances between points of production and consumption, and would be particularly important in countries like Italy, for instance, where we have a large geographical and seasonal oscillation in renewable electricity production, and let's say be a complement to, of course, the deployment of also other electric lines, for instance, for transporting the other main clean energy vector, which is, of course, electricity. So in this way, let's say, I always suggest to see hydrogen as a complement to electricity, not an alternative, of course. And by the point of view of transport, let's consider that making gas lines can be less problematic by an environmental point of view than making new electric lines due to the high power transport capability that the pipeline has, as suggested by this slide. Well, thank you for your attention, and I'm available for any question, of course.
Thank you, Stefano, for your interesting intervention that shows us how interconnecting and having an integrated approach is delivered to reach viable and to get viable solutions for the future. So now we leave the floor to Andrea Contin. We have seen lots of interconnection and an integrated approach among the different energy fields. Each energy source or vector has its pros and cons. It is possible to define a common long-term metric in order to evaluate the effective sustainability of the transition path.
Hello, everybody. The answer to your question is yes, but in the sense that in the last 20 years or so, standards for life cycles thinking approaches have been defined, categories identified, and by going beyond the single production facility and taking into account all phases of the production of a product or a process, which includes extraction of raw materials, use of natural resources, energy consumption, distribution, use, maintenance, recycling at the end of lifetime of a product, or recovery or final disposal if no other ways are available. So the main goal of this life cycle thinking approach is to reduce consumption reduce resource use, and reduce emissions to the environment. Also, by thinking in a life cycle approach about the socioeconomic performances, we can evaluate also this kind of say impacts. As far as the environmental part is concerned, the life cycle environmental assessment, which is LCA in short, takes into account the impacts essentially on human health, resource depletion, and ecosystem quality through several impact categories, which are interlinked in the sense that ecosystem quality is something which involves also human health or water pollution, air pollution, and so on. So this set of standardized categories has allowed to set up a good way to assess the environmental impacts. However, the world is changing very fast. We have interrelations due to introduction of new technologies in which traditional LCA analysis has limits, essentially because it gives a photograph of the situation in a certain point in time, which means that we don't have, let's say, the effect of introducing new products in an economy. So what we have to do is to explore not only the present impacts, but also the impacts in a different world which is changed by the introduction of the product. An example is a process which produces a green fuel using renewable energies. In this way, you substitute some of the resources like fossil fuel, and you get a credit for that because of this substitution. And the credit is a negative impact. But if you have a world where all the energy is renewable, there is no substitution anymore. So you don't have to get any credit for that. So in a way, you have to consider how the world is changed by the product and allow for a dynamic development of the situation. This is called, in technical term, consequential LCA, which let's say aims at considering how a decision changes the environmental consequences rather than attributing some performance only to a product. My research group is engaged in Ravenna in 2 European projects which deals with biofuels for aviation and for cars. And in particular, in the first one, we treat wastewater sewer sludge through some pyrolysis process. The scope is due to the fact that biomass is the only carbon-rich material source available, and the need for liquid high energy density fuels will continue, for example, for aviation. The LCA in this case considers all the competition between biomasses and food, feed, and fibers, and this let's say indicate that we have to use residues or residual biomass for this kind of production. Now, the consequential LCA analysis pointed out the importance of valuable byproducts like the use of biochar for carbon sequestration. So it reduces climate change and say the recovery of phosphorus, which is a rare material which can change the phosphorus market if the process is expanded as the project would like to. Another example for the need of dynamic modeling concerns material stocks and energy flows for implementing renewable energy production. And the main findings of this study, which is cited below, is the fact that the transition to low carbon energies implies a substantial increase of raw material use with respect to fossil fuel. In fact, we will build renewable energy infrastructures which generally will have a shorter lifetime with respect to present power plants. And if we want to recycle the material from these facilities, the amount of material which is included into the facilities lower than what we need for new plants. So we will have to change every 20 years our installation, and this requires materials. The need for dynamic modelings is essentially due to the fact that if you need a given amount of materials, you can have it by newfound materials or by scraps and the recovery of used material. But this is something which, let's say, depends on the quantities of material used 30 to 50 years ahead. And so you need a scenario which shows how the material use evolves with time. So this is also an example of the need for consequential LCA in the evaluation of environmental impacts. Thank you very much.
Thank you, Andrea. Andrea has highlighted the potential risk embedded in the natural resource depletion, metals, critical elements, even fossil fuel. Fossil fuel presently accounts for about 4/5 of the total energy supply, with consequent impact on carbon emission. So, Francesca, which is the role for fossil fuel in energy transition?
Thank you for your question, Edoardo. Actually, we know, okay, thank you for the presentation, which is coming in the meantime. Let's move to the next slide. Okay, so we know that the energy challenge we're facing is twofold. On the one hand, we have to meet the rapidly growing energy demand, and on the other hand, reduce emissions of greenhouse gases. Now, to fight climate change and pollution in alignment with the energy-related components of the Sustainable Development Goals set by the United Nations, we aim at implementing a major transformation of the global energy system. But we need to be aware that currently, some 800 million people around the world are still lacking access to electricity. So while it is true that the COVID-19 pandemic has temporarily reduced energy consumption. The outlook for energy demand shows that it will keep increasing significantly. And the reason is primarily due to the energy demand from India, Southeast Asia, Africa, and China. And all the data and analysis concur to show a situation where some countries or areas in the world are consuming more and more energy as they develop or boost their economy. To this end, they have a huge need of energy from sources that can be readily available at a reasonably low cost, and also that allow deployment of standard technology. And of course, fossil fuels are the first option to look at. The reason comes from history. Fossil fuels have changed the world and have prompted a revolution in terms of industry development, electric appliance supply, and transportation, which have improved substantially the quality of life of a large part of humanity. And by the way, the energy consumption increased over the last century because of the population growth. But the opposite is also true. The population could increase because life conditions improved so dramatically. Now, more than ever in the digital era, we cannot imagine living without electricity. Fossil fuels are successful because they have a high energy density and are easy to store and transport. And of course, there are alternatives to producing electricity. But let's remember that a country like China uses coal to satisfy more than 60% of its electricity energy demand. Additionally, some sectors still rely on combustion to operate, because at present there are no real technological options. Aviation and naval transportation is one of them, or high heat industrial processes. And I'm thinking about the iron or cement or glass industry. Now, the problem with fossil fuels is that they have a major drawback, which is called emissions of greenhouse gases. And we're learning at our own expenses how dramatic the impact on the environment and on climate can be. So we are now aware that a decarbonization process is needed, where decarbonization is the reduction in the carbon intensity. Excuse me about that, okay. So is the reduction of carbon intensity in the energy use. Now, if we look at the carbon intensity of the different energy sources, it is quite evident that renewables generate much lower greenhouse gases emissions than fossil fuels. So it is straightforward that we should move towards renewable sources, and this is in fact what we're doing. However, energy production from renewables is currently not able to meet the energy demands, nor it will in the next future. A change in the global energy mix is taking place, but we're not yet able to replace fossil fuels entirely. All analysts agree that we simply cannot walk away from fossil fuels because we're not technologically ready to make that shift. Let's make an example. I'm not an expert on renewables, but I asked some colleagues of mine to make little calculations for me. Let's take the case history of Italy and consider the electricity consumption per year. And imagine that we wanted to produce that energy, satisfy that energy demand entirely by solar power. Now, assuming that we could have ideal radiation conditions, we would need a territory which would more or less equal 50% of Tuscany to satisfy that. Or another example is, what if we wanted to use wind power again to satisfy the energy demand, electricity demand in Italy? Well, in that case, under ideal wind conditions, we would need to occupy 80% of the territory of Sicily. Last but not least, if we wanted to replace fossil fuels for transportation, then we will need to occupy some 60% of the plain for converting to biomasses. So this is the reason why reality is we probably should go from greener energy rather than for green energy. And this is not me to say so, but is the European Union. Because many zero carbon solutions are not yet market ready. And also the development of zero carbon solutions will require substantial research and innovation funding, with the consequence that it will not be implemented on a large scale for at least a decade, and thus will not contribute to emission reductions in the short term. So we need to aim at cheaper intermediate solutions to bring down emissions, and natural gas could be one of them, because greenhouse gases emissions from natural gas are significantly lower than emissions produced by oil or coal. Yet methane still contains carbon, so different routes should be explored to producing gaseous fuels with minimal or even negative greenhouse gases emissions over their full life cycle. This is to say, generation of green methane by combining zero carbon hydrogen and capture CO2, for instance. Now, this technology will have the clear advantage of reducing CO2 emissions in the atmosphere and using the existing infrastructures for methane. However, there is also the need for availability of CO2 and hydrogen in industrial quantities, as well as there's a need to balance CO2 and hydrogen streams with fluctuating seasonal and daily energy demands. Therefore, to deploy this technology, the issue of energy storage must be addressed. Energy storage involves converting energy from forms that are difficult to store to more conveniently or economically storable forms. Efficient batteries are now made with lithium, which, however, is a rare material and has become very expensive over the past years. So we cannot conceive a storage based on batteries for large energy quantities. A technological response might be chemical storage. The excess of electricity produced by wind and solar energy, which is intermittent by nature, could be used to produce hydrogen. Hydrogen could then be stored in deep geological formations and then produced back to surface to be combined with CO2 and produce green methane in a virtuous cycle. And I would like to thank you for your attention, and I'm obviously happy to answer any questions you might have.
So thank you, Francesca. You showed us that the energy transition is a complex path and needs a solution for both sustainability and affordability with an obvious result. So now we can start with the Q&A session. I have a question for Stefano. Stefano, you highlighted the role of hydrogen, and now Francesca stressed the power to gas concept, 2 molecules for the energy storage. But today, the word on everyone's lips is batteries, and market trend is impressive. So electrons can really replace molecules.
Okay, because I was, okay, thank you for the nice question. I was trying to switch on my microphone, okay. Well, it's a nice question because, let's say, hydrogen is surely expected to be one of the main players in the future decarbonized economy. We have seen it has a great potential to support an increased use of renewables, thanks to the storage concept as well. But this will happen as a complement to electrification, and as a complement as well to the use of other clean energy vectors, clean energy carriers like biomethane, biofuels in general. So there's a transition to be done where electricity is central, and the role of legislation, policy, and incentives will be crucial, we may say, to allow developing those new clean energy vectors like hydrogen and deploy that at a large scale, and let's say develop its potential that we have seen. So I don't see just a matter of competition, but really a complementary view with a progressive deployment of all the options that we mentioned. So also the power to gas option, which was mentioned in the last presentation, is appearing as a central possibility. But again, it goes through hydrogen. So it is a way to put together the recovery of CO2 and the use of hydrogen, speaking in a very smart way, of course. So let's say it's a kind of transition perspective where all those concepts should be taken seriously in consideration, and they have the possibility to cooperate, basically, to solve the very tough, let's say, problem of decarbonization, which we have seen how large it is in terms of substituting of current fossil fuels, which is something which could reach only in a long-term perspective, of course.
Thank you, Stefano. I have another question for Andrea. The need of energy storage solution is increasing with the pace of renewables, mainly because of lacking of a massive wave load or programmable decarbonized energy sources. You, Andrea, spent about 20 years in the field of nuclear research. Nuclear energy could be a potential solution?
Well, thank you for this question. I think the topic is very large, so I cannot really answer in full to your question. Let me just say that, first of all, the main advantage of nuclear energy is that it produces about 100,000 more energy per unit mass with respect to the conventional fossil fuels or chemical forces. Now, there are about 450 nuclear power plants in the world. About 30% of them would have to be substituted in the next, let's say, 10 to 30 years. So there is the need to build new one. Certainly, the nuclear power can produce the baseline energy for a big system. However, if you have a smaller system, each single nuclear power plant, 1 gigawatt is too much. So this is why there are about 70 different R&D efforts to look for smaller plants, which have several advantages in terms of safety and other. One of which is already functioning in China. These are called small modular reactors for the technical part. It is clear that nuclear energy has some problems about, let's say, how the public perceive it. On the other hand, an accident can have very large consequences. So you have to reduce risks by reducing the probability of an accident. And this is, with our knowledge today, is quite simple from the technical point of view, but there are still problems, let's say, social problems, how to manage the thing, where we have less certainty. Nowadays, the nuclear power plants costs a little bit too much on the too much side. So this is something which has to be reduced to allow for a diffusion of the plants. On the other hand, they are absolutely necessary to reduce CO2 emissions, because nuclear reactions does not produce greenhouse gases. Thank you.
Thank you, Andrea. A question for Francesca. Decarbonized programmable energy sources remain a big need. Coming back to present energy mix based on fossil fuel, so programmable, but of course not decarbonized. Do you think that carbon capture and sequestration technology can contribute significantly?
Absolutely. Thank you for the interesting question. Even the skepticals now agree that carbon capture and storage is part of the picture, must be part of the picture to accelerate reduction of the emissions in the atmosphere. Now, the point is, what else after storage? Are we going to store CO2 underground and leave it there? Or are we going to reuse it in a virtuous cycle? And this is what we would need to do to make the whole process economically valuable. Otherwise, the whole activity, the whole technology will remain a cost and will not be deployed extensively. So CO2 storage is part of the picture, has to be part of the picture, but has to be rethought in terms of making this something that generates value through reuse of the CO2 at a later time.
Thank you.
Thank you. Now we have a question for the audience today. I have a question from Professor Stefano. I didn't catch the difference between blue and green hydrogen. Could you please explain it again?
Yes, certainly. Good and important question. Well, first let me say that hydrogen by itself is colorless. So hydrogen is a gas with no color by itself. That is important to be said. It is also odorless, as an example, but as far as the color, it doesn't have physically any color. So the colors are given just for nomenclature, let's say, to briefly incorporate in the color the idea of how hydrogen is produced and from which primary source basically it is generated. Well, here in general, green hydrogen is intended as renewable hydrogen. So green should be an adjective pointing to renewables. So that could be either electricity from renewables, so photovoltaics, wind, which then through electrolysis makes available hydrogen. And that is a fully renewable, let's say, pathway for generating hydrogen labeled green. But renewable hydrogen, so green hydrogen, could also come from other pathways. So for instance, from biomass. Let's say the transformation of bio sources in general to hydrogen is also renewable and it should be labeled green as well. And also different uses, like for instance, the direct use of solar energy for thermochemical cycles, allowing to split water into hydrogen and oxygen is also another renewable based pathway. So that again should be green, shall be labeled green. The blue instead is the option basically of having a production which is based in particular on the use of natural gas, but not only that, so a fossil fuel, with CO2 capture, so with CO2 capture and sequestration or reuse of CO2. So that was exactly the concept that was mentioned by Francesca. When you still use fossil fuels, but you generate clean hydrogen with low or zero carbon emissions of CO2, thanks to the capture of CO2 and the storage, the permanent storage of CO2, for instance, in underground geological sites, or you reuse CO2 in a clever way, as was mentioned. Well, in those cases, you have the blue option, which is considered by most scientists an essential technology to sustain the transition towards a full decarbonization. By the way, there are also other colors in place because, for instance, hydrogen generated from nuclear electricity is sometimes mentioned to be pink hydrogen, and hydrogen generated still from hydrocarbons, but with the separation of solid carbon, and not the production of CO2, but separation of solid carbon, it's called pyrolysis, is sometimes labeled turquoise hydrogen. So there's a color, let's say, scale, basically individuating the primary origin and the production process.
So thanks, Stefano. So we have now a question for all our guests. It's about hydrogen and its different applications. So probably this new chapter of the clean energy is demanding a new optimization, new monitoring, and probably it will lever also artificial intelligence and advanced technologies. In your opinion, which can be the link between the clean energy and this and automation and artificial intelligence? So probably I will leave the floor to Stefano to complete the view, and after to the others. Thank you.
So, artificial intelligence and let's say is one of the emerging fields in the use of wide data sources and interpretation of data sources. It will sure have, let's say, the capacity to be related to an evolution of the energy sector towards an increased decentralized generation of energy. So think to all the topics of interaction between different, more and more distributed on a small scale, let's say, actors of the energy field, like has been happening with the installation of photovoltaics, and the necessity of making more complex the interaction between producers, the so-called prosumers, and the electric market in general. So I believe that starting from that, and also from several other point of views, there will be an increasing need of innovative approaches to the management and the optimized management of increasingly complex and interweaving energy infrastructures, like is the case of electricity, but also we mentioned the distributed production of gases like hydrogen, like biomethane or others, and their possible interaction with the gas grid and with a branch network, let's say, of final users on the territory as well.
Thank you.
Well, may I add something about artificial intelligence and big data influence on renewable energies? We are using satellite data, for example, to map the biomass presence on the territories with large sets of data in order to assess the amount of waste biomass and or bare soils to produce biomass for energy purposes without interfering with the food and feed. So this is something which is evolving now through all the European satellites we have available.
Okay, just to complement with the colleagues have said, I believe the integration of artificial intelligence in the energy sector is just as unavoidable as it is in any other sector of our life. It's very pervasive, adding value and making us dealing with the data and the information and the equipment in a way we could not conceive before. So it is absolutely evident that there will be a major role of artificial intelligence in the energy sector as well.
Thank you. Now it's time for a question that is really interesting, maybe a bit provocative, that require a comparison between power gen, which use fuels, and solar energy. Maybe this is the field of LCA's analysis. Andrea, what do you think?
Let's say, for sure, the environmental impacts of fossil fuels is larger than of solar energy. Even if solar energy needs more materials, but you have to consider all the factors coming in. In particular, the emissions of CO2 from fossil fuel has not been accounted for in the economics of the fossil fuels up to now, because air is, our atmosphere is very large and it can absorb a lot of gases. But now we are clearly looking at the effects of these emissions. So this is why this kind of reasoning is more and more used, which includes everything in the picture. It is also clear that you may have more emissions, more impacts on one category for one technology and more impacts on another categories by the other technology, which makes things a little bit, let's say, you have to look into the results really in detail. Thank you.
And now we have a question for Francesca. Which strategic decision should be made to reduce the use of fossil fuels?
Strategic decisions must be made in terms of economicity of the choices we're going to make. Investment in research innovation, it is the first step, but the second and necessary step is political decisions and economic decisions so that the options will be economically viable. I'm sorry if I stress the word economic and economicity and value making, but this is the only way we can really get out of the situation. Problem being that developing countries are the ones currently having larger emissions. So as much as we strive and we are good at reducing our emissions, we need to convince and convince in a sensible manner the other countries to reduce their emissions. So, it's not, if someone in Norway does not use water, will not help Africa to get out from drought. So that's the same concept. So we need to have global solutions, and for global solutions to be accepted and implemented, there has to be a general political strategy which is agreed upon and which is somehow generating values. Or otherwise, let's put it the other way around, or there has to be a severe cost for not moving towards renewables.
I see no other question from the audience. I have one about a problem that has been touched just a light during this conversation, but I think is a great importance. That is the end of life or circularity of many forms of energies. We start discussing about nuclear plants that have to be renewed. For sure, we have to decommission some old plants, but also the new, very expanding market like photovoltaic. We install about 1 million panels per day, and in a 20, 30 years, we have to think about a new life of this element. The same for batteries or many other sources of vectors of energy. I ask all the speakers just a very brief consideration about circularity and end-of-life consolidation of generation and sources and in the energy world.
Okay, maybe I can start. What you said is very, very interesting and absolutely needed. We should apply circularity to every single aspect of our lives. The consumption cannot go on forever. We have very clearly understood that resources are finite. And so there is absolutely no doubt that we need to be good at recycling. It's really the energy, the perspective of the society about energy, about food, about water, about anything that concerns our life that has to be completely change mindset completely. And we need to take that step. That's the next step that humanity will have to take to survive on Earth.
Well, if I may comment also, there are things which are easy to recycle, like an aluminum can is particularly easy to recover and reuse. But there are materials which are very rare or are becoming rare now, like cobalt or rare earth, which are a base for our electronics, which must be in a way or another recovered, and which need a lot of research and development yet. So I see this kind of specific recovery as our future R&D necessity.
Okay, I fully share the views of which have been expressed so far, let's say, but I would also like to add a bit of provocation, or let's say provocative sentence. Let's say, of course, it's not only important the circular perspective in recycling, but also the sustainability in production since the beginning. Let's say the advent of new technologies, like for instance the increased use of batteries for mobility and transport, is nowadays happening with let's say a kind of production chain still is way far from sustainability. I mean, we typically care a lot about the issues of greenhouse gas emissions, but people don't care that much about the way cobalt is extracted nowadays in countries in Central Africa with the involvement of work of kids and minors and not non-sustainable modalities, definitely. So when we see an advent of a new technology, we should be aware that, for instance, increasing quantities of new materials will be needed, and we mentioned cobalt as an example for batteries, but there are others as well. And let's say before reaching the recycling era, we need to face an increasing consumption era in which all the sustainability in the production must be taken into account, and frequently that point is overseen, oversight, let's say.
So thanks a lot. I think we don't have any other questions from the audience, so let me have the chance to thank all our guests for this interesting discussion. I think this afternoon we showed how complex is the debate about the energy transition path, and how we need to meet and discuss together about the different perspective of this challenge, because there's no single solution, and the dilemma to reach a clean and affordable future energy system needs the involvement of all the stakeholders involved. So university, students, researchers, but also companies, contractors and institutions. So this is the aim of our 15th edition of the OMC. We want to discuss the ambition, the challenges we have to front, enlarging the boundaries of our activities, including different sources of energies. We want to give new impetus to the event, because we consider OMC and Ravenna the ideal place for discussion about synergistic development strategies, as well as a way to catalyze collaboration in order to convey a positioning of the industry. Today we discussed a lot about sector coupling. We want to have an ideal place in order to reach the possibility to find common occasion of development. So the theme of the event of our next edition, that will take place in Ravenna next 28th, 29th of September, is Rethink Energy Together: Alliances for a Sustainable Energy Future. And as said, the alliances are the key lever to face the transition. So this is why the OMC event will invest on creating alliances, focusing more and more on partnership between all the stakeholders involved. And we want to pursue the dialogue in order to convey unaligned goals and pursue climate awareness.
For this reason, we have defined a new public area within the event, focus on meeting with students, researchers, startups, other companies, youngs. This is the innovation room. It's an absolutely novelty for MC, and we host a series of workshops and initiatives addressing universities, schools, to attract and get them involved in the energy transition path. Some of the events in the innovation room, an event dedicated to startups, to share innovative ideas and facilitate the cooperation between networks with energy companies, young researchers, and potential stakeholders. Also a call for ideas from the Mediterranean challenges, addressing North African companies and universities on what they think about how they are preparing for the energy transition, as well as investigation, potential partnership, alliances, opportunities between North and South, East and West Mediterranean. And finally, an hackathon to gather brilliant minds to find solution, ideas, projects. On this, we have worked with SPE and Accenture to organize an hackathon relating to UN Agenda 2030 of the SDGs and directly addresses to students and young professionals in the age of 20 to 30, the OMC 2030 Hackathon. It's now the time to discuss about our partner, SPE and Accenture. So I invite on the floor Paolo and Fausto in order to know about something more about this event. We can start with Paolo. SPE for sure is in line with the OMC approach on energy transition, with a special focus on the importance on involving young students, young professionals. How do you think this mission can be supportive to OMC and making and creating synergy and the hackathon we are discussing now? Paolo.
So thank you, Edoardo, and thank you also for giving me this opportunity. As you have introduced, indeed, the SPE Italian section is expanding its vision to include not only historically petroleum engineers, but also the professionals of the energy sectors in general. It has also introduced the energy transition principle into its mission. I would like to remind that one of the SPE Italian section main targets is to promote the knowledge and the development of the low carbon energy sources in order to enable a gradual energy transition. So in this way, SPE started a decarbonization path in which professionals from the world of energy brought their vision on the matter in a series of webinars. 3 of them have been already occurred, and the 4th one will take place in September of this year. So in SPE, we believe that 2 factors, basically attracting new students and young professionals and promoting the knowledge and development of low carbon energy sources in order to allow for a gradual energy transition, are really fundamental for the growth of our organization. So SPE Italian section gives great importance with the dialogue with the students. And also I would like also to point out that we have today 3 student chapters. 2 of them are in the Polytechnics of Turin and Milan, and 1 in the University of Rome. So this dialogue with the students and with the younger professional is really key, because in this way we can promote the identification of the young professional within the organization itself, and with a special attention who is entering the world of oil and gas and the energy directly from the university. So this attention, I would like to also to stress, was particularly captured by Giovanni Paccaloni, that was a mentor of many young people. He was the promoter within SPE International of this formalization of the young professional group. And in addition to the classic oil and gas teams, so we have launched a series of events that deal with the decarbonization part of the industry and with the technological innovation, in line with the global vision of SPE International, which are really key factors in order to achieve the net zero goal by 2050. So we strongly believe that the collaboration with this conference will enhance these messages because we can broaden the dissemination to professionals and young people. We can create new opportunities for them, and we can collect their point of view and also the contribution of all the energy specialists. So the OMC event and the hackathon focus on the energy transition and on young people aged between 20 and 30 years old. So that is exactly the same group of students and young professionals that are pampered by SPE. So it fits well with our goals. So it is supportive because we are exactly in line with our mission in order to raise awareness of the energy transition. And at the end of the day, I really believe that both OMC and SPE can gain a great human capital from this opportunity.
So many thank you, Paolo. So now we leave the floor to Fausto, so to our partner Accenture. So why Accenture has decided to be a sponsor of the OMC event, and how we'll collaborate on the innovation room.
Thanks, Monica. Edoardo, it's a pleasure to be here today. Thank you for hosting me. It's a pleasure and an honor for Accenture to be here. So to answer to your question, Accenture has a strong commitment in sustainability. We are very much committed to work and contribute to a better world, more sustainable and more responsible. So we are perfectly fitting with the purpose of your conference, and that's why we decided. The second bold and relevant reason is that we like to see ourselves as a young company. We hire a lot of young people and young professionals from the academy and the university. And so our second big commitment that fits very well with the spirit of this conference is to be able to create an environment for the young professional to express themselves, to find ways and to contribute to this better world, which is at the end our mission. So a couple of words of what we are doing in terms of bringing ahead our effort on sustainability. So we are committed to pushing ahead the United Nations Global Compact. And so in that sense, we push ahead all the SDG, the Strategic Development Goals. Within that, inequality, human rights, and climate actions are probably the most important for us and the most relevant in the action of all days. We as Accenture are, by the way, a big community of people around the world. We are half a million folks working in more than 120 countries. We are very present in Italy with a relevant practice, but we are spread all around the world. So our commitment starts first by our daily action. So being 500,000 people, we have to contribute to make this world more sustainable. Some of our initiatives that are bringing us to be net zero carbon by 2025, this is our goal and commitment, pass also through the fact that we promised and committed to eliminate all our e-waste by 2025. So we are giving away or recycling all the waste that is coming from servers, computers, furnitures, and this is an example of what we want to do. So we are very happy to sponsor this initiative and the hackathon, because through the hackathon, we think we can give a sense of our action, animating it. We have a practice within Accenture called Accenture Interactive that is specialized in design thinking, setting up events like hackathon, like the one that we will host in Ravenna. And so we are more than happy to bring our capabilities to make these events successful.
Thank you, Fausto. I think now we are ready to discover more about the hackathon. So can you tell us more about what is going to happen in Ravenna next September?
Yes, not too much, because this must be a surprise as well. No, but to give you a very high level sense of what we are going to do, this is the typical way we organize the hackathon. So there will be a morning session where we are going to have some session with our specialists that will animate a design thinking working session. In that one, we will have exercise of ice breaking in order to allow the people and the participants to feel themselves comfortable, to understand what is required, and to start working on the ideas. We will have specialists of our team in the rooms and together with the participants in order to help them understand and structure their work. And we will conduct the session together with them in order to have the work done. In the afternoon, all the indication will be given, and so the people will concentrate on elaborating their solution to answer to the power question. So the afternoon will be the work session mainly, where we think the brains of our participants will work at speed. We will be there supporting, coaching, and structuring with all the material we think can be worth for the session. At the end of the afternoon, as usual in an hackathon session, we will have the judgment, and so a plenary where we will understand which are the solutions that better fits with the purpose of the request.
Thank you. And now we are ready to disclose the power question for 2021 hackathon. Paolo, the floor is yours.
Thank you, Edoardo. So I have the duty to uncover the power question, and this is the power question. So in order to ensure access to affordable, reliable, sustainable, and modern energy for all in the short, medium, long term, what do you think it is the optimal combination of energy carriers for the various forms of transport and utilization? And how this should evolve from 2025 to 2050? What difficulties or critical factors do you see in achieving your vision, and how do you intend to overcome them? Under what condition could this evolution take place? So, well, guys, this is really a big challenge. Who is better than you that can give ideas and new proposal to forge a world in which we will live all together? I trust really in your abilities and vision, and I really can't wait to meet all of you in September in Ravenna. So thank you very much.
Thank you, Paolo. Thank you, everybody. So, Edoardo, I think it's been a really fruitful afternoon. Let me thank our guests for the interesting discussion and our partners for supporting us in the organization of the Energy Hackathon. Thanks also, everybody, for being here with us. We invite you to Ravenna to have the chance to finally meet in person.
And I invite you to register to our hackathon. You can find all the details on our website, www.omc.it. See you soon.
Bye.
Bye.